Okay, team, hey, this is 5.4. We're solving systems of equations, except for now we have these special cases, they're called. And basically, a special case is anytime your lines never intersect. So this is like, let's recall, this is a normal system. You have two lines, they intersect. Our solution is where they intersect. A special case is when you have two equations and it turns out they're actually parallel lines and they never intersect. We call that no solution. And then another weird case is if you're given two equations and you realize after a few algebra steps that your lines, or sorry, your equations were actually the same equation. And so when you graph your lines, it's like the lines are just it's the same line, like two lines right on top of each other. And that's called infinitely many solutions. So these are our special or weird cases. And there is a trick. There's a trick to recognizing when a system of equations is going to be no solution or infinitely many solution. And I'm going to tell you that trick. So here's an example, by the way. Here's a system of equations. And I already can see that these are parallel lines. And I'm going to tell you how I know. So I know that because a lot of these systems you have two lines that are in slope-intercept form. And to tell if two lines are parallel, they have to have the same slope. If they have the same slope, then they are parallel lines. Parallel lines will never intersect. Therefore, it'd be no solution. So let's go back and look at that example. And I'm looking for the m, the number in front of the x, and those are the same. So I know these are parallel lines. Now, the y-intercepts are different. If the y-intercepts were the same, then the equations would be exactly the same, and that would be infinitely many solution. All right, so here we'll go ahead and graph the lines then. You can see what it'd look like. There they are. Okay, they each have the same slope of up 3 over 1. Now, if I was going to use the substitution method by taking one expression for y and substituting it into the other equation, then I would also find, here we go, substitution, we would find that the variable is going to cancel out on both sides. So I'm subtracting 3x from both sides now. Cancels out, it leaves me with fake math, which you might recall from chapter 1. We did a lot of these kinds of equations. So fake math, the variable cancels out on both sides. -3 certainly does not equal 1. And if you recall, that means it's no solution. So anyway, two different ways. For the most part, guys, you're just going to need to look at equations and graphs and tell me whether or not they are infinitely many solution, no solution, or one solution. So, okay, scholars, that is 5.4. You have 3 questions on your online assignment. Have fun.